Hi everyone, welcome to Introduction to Energy Law. My name is Leonie Reins and today we will look at what energy law is, why it's a bit different from many other legal fields, and how we can think about regulating new technologies in the energy transition. We will also walk through a concrete example, grid congestion, to see how different regulatory approaches can be used in practice. At the end of this session, you should be able to answer three main questions. What do we mean by energy law? What is the law and technology model and how does it help us in analyzing regulation? And what are different regulatory modalities, meaning different ways society can steer behavior beyond traditional rules? At first glance, energy law may appear to be another sectorial field, but it's actually much broader. Energy law is an umbrella field that integrates tools, doctrines, and regulatory techniques from multiple areas of law, including environmental law, market and competition law, administrative law, property law, and increasingly climate law. In this sense, energy law is structurally hybrid. Because of this hybrid nature, energy law tends to be reactive. Energy systems evolve quickly. Think about smart grids, hydrogen, offshore wind. But legislation and regulatory mandates move much more slowly. So, the law often lags behind technological and market developments. Second, energy law lacks fixed regulatory principles. Unlike environmental law, which has clear guiding principles such as the polluter pays principle, energy law is usually guided by the energy trilemma, balancing sustainability, security of supply, and affordability. These goals often have different directions. And finally, energy law is problem-based. The laws are developed in response to concrete energy challenges. These challenges could be technological, geopolitical, or market-driven. A good example is the EU's REPower program, which was created to address energy supply concerns after geopolitical shocks. So overall, energy law is reactive, dynamic, and shaped by real-world problems rather than by a single doctrine. Now let's look at the law and technological model, which helps us analyze how new technologies in the energy sector should be regulated. We start with a new technology, for example, electric vehicles. The first step is simply to understand it. What are the key features? How does it work? And what issues does it create? Then we look at the risks and problems that arise. We ask whether these problems are already visible, which socio-technical context the technology is embedded in, and who the key stakeholders are. And, of course, what the existing regulation currently say about it. At this point, we check whether there is a regulatory gap, whether the existing rules actually cover the issues created by the new technology. If there is no gap, intervention may not be necessary. But if there is a gap, then we need to think about regulatory action. Once we determine that intervention is needed, we ask 5 basic questions. Who should intervene? What needs to be addressed? When to intervene? How to intervene? And why is this intervention justified? This is the model in a nutshell. Regulation isn't only about formal legal rules. Lawrence Lessig describes 4 modalities of regulation. First, architecture. This is regulation through system design, the way the physical or digital infrastructure is actually built. Second, markets. Here, regulation works through price signals like tariffs, subsidies, taxes, and incentives. Third, law. This is the traditional modality. This includes binding and non-binding rules, prohibitions, permitting regimes, and compliance obligations. And finally, social norms. Behavior is also shaped by expectations, cultural norms, and what people consider acceptance or responsible. In energy law, we often need a mix of these modalities. because no single one can solve complex challenges on its own. Let's apply the modalities of regulation to a real issue: grid congestion. There are situations where the electricity network can transport power where or when it's needed. First, architecture-based solutions. These focus on the physical and digital design of the system. That include reinforcing the grid and using smart grid technologies like smart meters and digital control tools. This helps to manage flows in a more flexible manner. Second, market-based solutions. Here we use price signals to influence behavior. Congestion prices charges higher prices in contained areas at contained times to signal scarcity. Time of use tariffs work similarly. Electricity becomes cheaper in off-peak periods and are more expensive during peak hours, encouraging consumers to shift their demand. Let's continue the grid congestion example and look at the law and social norm angles. First, law-based solutions. Here, the regulator can impose obligations on DSOs. For example, requirements to manage congestion in specific ways. Law can also establish priority rules: who gets access when capacity is scarce and how curtailment is ordered. Then we have social norms. Think about rooftop solar, for example. In many neighborhoods, having solar panels has become the responsible thing to do, and not having them can make you feel like you're not keeping up. Social norms also matter for off-peak use. If public campaigns make off-peak use feel like the right and normal thing to do, people tend to follow that pattern without thinking too much about it. Thus, we see that managing grid congestion typically requires a combination of modalities working together. So, to wrap up, we started by defining energy law and discussed why it's dynamic and often reactive. We introduced the law and technology model as a way to analyze how new technologies can create regulatory gaps and uncertainties. And we worked through the four modalities of regulation: architecture, markets, law, and social norms, using grid congestion as an example. Thank you very much for listening.